Hello guys, Assalamualaikum warahmatullahi wabarakatuh and a very good day. So today I'm going to you how to plot a CV graph and how to export the CV graph from Versa Studio. Okay, I have run the cyclic photometry at multiple cycles. So as you can see from here, there are multiple cycles. So I run from 5 millivolt per second, 10 millivolt per second, followed by 20 millivolt per second until 100 millivolt per second. So because I'm going to do a device fabrication, so I going to show you how to do in the research paper to plot side by side the negative electrode and also positive electrode, because in asymmetric device we are combining negative and also positive. So out of a lot of cycle here, this is the sample for activated carbon. So the activated carbon potential window is from 0 to -1. So I'm going to plot side by side with my positive electrode from 0 volt to 0.5 volt. So you're going to see how it will turn out. So this is all. So I'm going to select from the Versa Studio. You just click here, none. So we're going to select. This is the second cycle for the last plot here, which is 5 millivolt per second. So I'm not going to pick that. This one, second cycle for 10 millivolt, 20 millivolt, 30 millivolt, and also 40 millivolt. So what I'm going to do, I just going to choose 40 millivolt per second. Actually, it's optional. You can choose whatever scan rate that you want to do as a comparison of the potential window. So I choose the 4 millivolt per second. So you just click here, copy to clipboard. So after copy to clipboard, open the Excel. From Excel, this is activated carbon. So we're going to paste Control V. So when Control V is going to paste, then this is current. I'm going to change to the current density. So because I know that my mass, and I'm going to divide my current by mass, so I'm going to get the current density. So this is my current divided by mass is 0.5 milligram, 0.005, no, 305, 1, 2, 3. So 0.5 milligram. Then I click enter, and from this side, just double click. So I got my potential for the activated carbon. Okay, easy, right? So now I'm going to see for my working electrode. So for my working electrode, I already plot my working electrode. Let's see, let's find whether I can find the CV2 electrode system. No, I already plot the CV for 3 electrode system. So this is my CV for 3 electrode system. Okay, so here, yeah, because I plot until 5 millivolt per second, so we cannot choose 40. So we cannot choose 40. So we need to choose from the Versa Studio 5, because you need to have the same scan rate. So your comparison will be valid. So again, just pick the 5 millivolt per second and copy to clipboard, and click here and Control V. Okay, then we change again to the current density, and here equals to current divided by your mass, 0.005, no, 305 milligram, 0.5 milligram, because this is the thin film, that's why the mass quite low. Okay, then what we're going to do, we're going to paste on our origin. So before that, let's choose our positive electrode. So based on the positive electrode here, we got the pink color here, 5 millivolt per second. We're going to copy that data first. Okay, this is the data. Then how you know? So because this is my graph, my origin, I know which is the position. So it start with what we call that, it start with 1 millivolt per second and end with 5 millivolt per second. So 5 millivolt per second, the graph is at the end. Okay, this is the graph. Okay, I just control copy. I go back to the Excel sheet, and here I paste. Okay, so from here you can see I already have my positive and my negative electrode. Let me make it a little bit tidy. Okay, so this is for activated carbon, and this one for our positive electrode. So what I'm going to do, I'm just going to copy both of them, control copy, control C, and goes back to the origin and make a new workbook. Okay, this is new books, then control V. Then everything already pastes on the new books. Okay, so set our x-axis. This is x-axis. Control set as X. Okay, then we're going to plot. Click here. Okay, after that, click Control Y, Control X, and also Control Y. So then we're going to plot our graph. Ta-da! This is our graph. Okay, as you can see, this is our graph, what it look like. And yeah, then we're going to change the axis. This axis here is a current density. So we have our current density. The unit is ampere per gram. Okay, then after we have our current density, then you need to label your x-axis. So for your x-axis, the label is the voltage. So you need to do labeling. Okay. Wait a minute. Let me double check for you. Okay. So we have a current density. This one you can use either voltage or potential. And let's see, let me do potential. Potential volt versus your reference electrode, whereby it is we are using saturated calomel as CE, saturated calomel electrode. Okay, by right, I think that's all. Yeah, that's all. Then we just need to double click, go to here and here. We're going to change the top. We change the axis. Here, non-axis, but we want a line, a solid line. Same goes to here. And the right hand side also we want to show the axis as none. Then click OK. So now we already click OK. So after that, then you already got your graph. Okay, this is your graph. So because then first of all I need to increase the thickness, and yeah, that's all. So you just need to rename your sample and also rename the positive electrode. For example, this one I rename as activated carbon, and this one I rename as bimetallic oxide. For example, is BMO. Okay, depend on your acronym. So just drag here and bring to here. Then your graph is finished. You can export your graph by doing file, then export the graph. And after that, what you're going to do is, okay, this will put up. So click here, click PNG. Okay, then choose the location. So let's just put in the desktop and click OK. So we are finished. Okay, then the next step is what you're going to do. You click your graph in the desktop and double check. Is it okay or not? Okay, waiting for loading. Okay, then this is the graph for comparison before you are doing your device. Okay, I think that's all. See you again. Bye.